Okay, hi everyone. Welcome to Aerospace Manufacturers Navigating Through the Wake of COVID. My name is Pete Tarbox, and I'm an aerospace sales director here at aPriori. I'm joined by Craig Fisher, an aPriori product manager. Before we begin, a few housekeeping notes. The attendee lines will be muted throughout the session. For questions, please use the chat panel on the conference website, not the Zoom chat. That's costinsight.com. Look for the chat panel. If we have time at the end, we'll answer as many as we can. If you want to follow up with Craig or I, feel free to use the meeting scheduler in the conference website. On that site near the chat panel, choose People, select me, Pete Tarbox, or Craig Fisher, and schedule a meeting, or reach out to our emails as shown in the last slide. We're recording the sessions and making it available to everyone who is registered. It will be available on the website within 24 hours. The presentation is already available to you in the files panel. So let's begin. So I don't think any of you are surprised to hear that aerospace has been deeply affected by COVID. Today, we're going to take a look at some of the specific impacts by industry segment, how companies are responding, and what the future opportunities are. And then Craig will help us take a look at how aPriori can help A&D companies meet their goals to survive and thrive. If you saw Stephanie's kickoff, this slide will look familiar. It can apply to any type of manufacturer. So as supply chains have been disrupted, engineering teams have been displaced and question if current product plans are still relevant, and downstream suppliers fight to stay open and survive and compete in a smaller market. How have companies initially reacted? How will they recover through next year? And what are their opportunities to emerge better than before? The answers, of course, differ across industries and even within aerospace segments. Today, we'll apply this map to commercial, defense, and space. So in commercial aerospace, we're seeing a major drop in traffic. August saw domestic travel at 49% of 2019 levels, hurting single aisle demand where manufacturers already had a large backlog. Boeing's situation, of course, is compounded by the MAX. On their Q3 earnings call, they said it will take 2 years to deliver the currently built and stored MAXes. International travel demand is much worse at only 12% of 2019 levels. This has a major impact on what was already a shrinking twin aisle market. The impact will be felt for decades. Boeing forecasts a $200 billion pandemic-related drop in market potential over the next 10 years. Supply chain disruptions. We saw a number of facility shutdowns. For a while, companies were scrambling to get certain parts and were impacted differently based on how vertically integrated they are and where their supply chain is. Tier ones like Spirit and Collins have seen major drops in demand, and that of course flows down to the sub-tiers as well. Competitively, this has favored some companies over others. Comac has had time to continue development of the C919, while suppliers with the defense mix had an advantage of being deemed essential and could stay open while their competitors shut down. And companies that started with a strong cash position, of course, are better off today. So how have companies reacted? Their first focus was on safety. Like other industries, they enforced social distancing, deep cleaning of facilities, and enforced work from home policies. They shored up cash positions. Commercial aerospace is capital intensive as it is, so all the big players are leaning on their finance execs to secure new financing with notes and loans, restructure debt, and maintain cash by doing things like using stock to fund pensions. They also took steps to reduce their immediate cost structure. We saw layoffs, furloughs, renegotiation of agreements with suppliers, and really they were doing whatever they could to find parts where they could. So how are they now recovering? Well, companies have been surprised by the efficiency of their workers from home. Boeing is forecasting that it can reduce its office space permanently by 30%. Some are consolidating manufacturing, for instance, the 787 moving to Charleston. A number of customers are using aPriori to renegotiate LTAs and focus their engineers on getting costs out of existing designs. Looking forward, they're asking, is my product planning right for the market anymore? Boeing says no with the NMA. It's an opportunity to focus on sustainability. Airbus announced 3 hydrogen-powered airplanes by 2035, of course, nudged along that path by government money. Engine manufacturers are committing to meet the move to these more sustainable alternatives. Companies are also looking at how they can drive risk out of their supply chains in the long term and how to respond to a new competitive environment. While Boeing and Airbus both may lose share to Comac in the Chinese market, Boeing last week actually upped their forecast in that region. I've spoken so far about larger airframes, but what about business and private jets? The landscape's going to be very different. In defense, they, at least in the medium term, is in a better position, but they're not unaffected. They experienced production slowdowns. F-35 production, for instance, was immediately halted in Italy and Japan, and Lockheed won't be back on schedule with the F-35 until the end of 2021. Supply chain disruptions haven't been as prevalent, but those dependent on specialty suppliers have experienced gaps. While a lot of their supply chain is in country, some important gaps have been identified. For instance, the US only makes 12% of the microelectronics used in its defense systems. Overall, though, they're stable and expect to be for at least 2 years. Looking back at a pure play like Lockheed, it's grown in every segment of its business this year and is forecasted to do so again next year. They're aggressively hiring right now. Longer term, though, there will be downward pressure on defense budgets as countries work to draw down the deficits created by COVID. So what are they doing about it? In some ways, the same thing as everyone else. One unique thing is that companies with a foot in both defense and commercial have been finding ways to balance the offsetting cycles. Textron's defense-heavy Bell Flight opened an office in Wichita by their commercial Textron aviation business to take advantage of engineering resources there. As they recover, companies are continuing to shore up existing supply chains. Some are shortening their payment schedules to keep their supply chains funded. Some may even acquire specialized suppliers. On the same path as Boeing, Raytheon says they may close 20 to 25% of their office space. So like commercial, they need to support a larger work from home population. Companies need to invest in tools and methods to protect sensitive government data. Companies need to make sure they're well positioned for the coming downturn. So we're going to see a solid focus on program execution and increased investments in R&D. And in the future, well, look, defense is all about the programs. Customers' needs are changing. So the plans developed last year to support legacy platforms may have shorter life than expected, or perhaps those platforms will be extended and new programs will suffer. We do know that increased cyber attacks are creating revenue opportunities for cyber solution providers, and we may see some public-private partnerships evolve in response to the microelectronics supply chain risk. And finally, companies have the opportunity over the next year to figure out how they will enable their employees to collaborate around new product development and supplier management in a remote environment. On the space side, there are even bigger differences between players in the space sector. Your focus really matters, whether you're launch services, satellites, defense or commercial, and company size, small or large. Intelsat filed for Chapter 11, while SpaceX has been signing long-term government contracts. We all know that last week they sent 4 astronauts to the space station. The space value chain is very sensitive, made of highly specialized suppliers across the globe, creating a challenge for a number of players. So how did they react? They had the same initial impact on production facilities as other sectors, with a more severe impact on their supply chains, which created an opportunity for some onshore suppliers to get into the sector. As they recover, companies will continue to evaluate how they can reduce risk through things like acquisition or redundancy. And looking forward, companies will be watching where the market is going. On the government side, what's going to happen to space exploration budgets in the next 5 to 10 years? SpaceX is becoming a true low-cost defense player. How will established players like Raytheon and United Launch Alliance respond? Commercially, what's the future of communications technologies? Starlink may be hitting at the right time to support a global increase in work from home. Is C-band taking off? Companies like SpaceX and Blue Origin are making the market also more cost competitive. So the bottom line is a lot of businesses have been stripped back to their skeletons and now have the opportunity not just to recover, but to become something better, more nimble, more adaptable, more digital. aPriori can help companies to more easily develop these new paths forward by leveraging digital twin with our digital factories. Manufacturers can collaborate across the product development process to make better design, sourcing, and manufacturing decisions, drive product costs lower, and create high-value products in less time. So now Craig is going to show you some of these ways. Craig?
Okay, thanks, Pete. So let's take a deeper dive into aPriori's capabilities across aerospace and defense and some important use cases for the industry. Aerospace has been at the cutting edge in embracing advanced manufacturing processes. As we saw a few slides back, one of the major initiatives being made by companies is toward greater sustainability and being more environmentally conscientious. In that vein, two areas that have become increasingly important are the use of composite materials as well as additive manufacturing. Composites are characterized by having high strength and stiffness to weight ratios and resistance to corrosion and fatigue. They can be designed to specific loads, and their use can significantly reduce overall part and hardware count. The upper image shown here is a fuselage skin section being made by an automated tape layup process. Additive manufacturing is characterized by typically complex geometries that may be difficult to machine. They can have higher densities than investment casting and have relatively low tooling costs. The lower image here is of a fuel nozzle made by direct metal laser sintering. Common materials in additive include stainless steel, aluminum, titanium, and Inconel. And as airlines are looking to reduce their MRO costs and increase the uptime with a smaller fleet, additive is becoming an increasingly important way that they can reduce MRO. But as impressive as these technologies are, one point to make is that knowledge of their cost structure has historically lagged. You could say that cost was an afterthought. aPriori has cost models for both composites and additive and can provide valuable cost insight. So there's a lot of part types and subsystems throughout an airplane. This image shows some of the principal part types that are supported and costed in aPriori. I'm not going to read through all of these here, but I'll highlight a few, such as advanced composites, additive manufacturing and powder metal, aluminum extrusions, investment casting, ultrasonic inspection, both A and C scan, sheet metal hydroforming and stretch forming, anodizing and various electroplating processes, and to address the increased electrification within airplanes, PCBAs and wire harness. So for those of whom are not yet familiar with our solution, let's dig into the key elements of aPriori. We start by taking all the different types of cost and manufacturing data we just looked at on the last slide and connect them into one shared cost database. And further, we combine all of this carryover cost information with cost estimates of dynamically changing new product designs that are generated by aPriori's automated cost engine. We provide more than 270 mechanistic cost models that let your team initiate early stage estimates that give them insight into the cost of their trade-off decisions and gives them a better chance of meeting target costs consistently. They will leverage aPriori's 79 regional data libraries that include a comprehensive collection of geography-specific information, such as labor cost and overhead cost. And we give you the ability to generate detailed cost estimates of individual components and complex subassemblies or functional groups. aPriori has continued to develop increased capabilities for aerospace and defense. On the additive manufacturing side, we currently support DMLS, SLS, and SLA. And some of the key features include the ability to simulate different options for the build direction, to evaluate trade-offs for material cost, to identify the support structure, and to understand the optimal nesting layout. Here we have an image of a part that could be made either by additive, by machining it from bar stock, or by casting. And we can evaluate the relative cost by running this part in those different process groups within aPriori. On the composite side, we support three main processes: hand layup, automated tape layup, and automated fiber placement. We recently added support for machining of cores and water jet cutting to trim the part periphery. We support a variety of modeling formats, including FiberSim, CPD, and model-based definition as well. Another area that aPriori has recently expanded support for is generative design, which is becoming more widespread throughout the industry. aPriori has partnered with Autodesk's Fusion 360 to provide cost analysis on the generative design platform. If you're not yet familiar with generative design, Autodesk describes it as a technology that mimics nature's evolutionary approach to design, in which thousands or even millions of design choices are cycled through, testing configurations, and learning from each iteration what works and what doesn't to find the most effective design. The image here is what's called a bionic partition that's being developed by Airbus. Airbus views generative design with algorithms based on two growth patterns found in nature, slime mold and mammal bones. And so the resulting design is a lattice structure that looks random, but is optimized to be strong and light and minimize the amount of material. So switching gears a little bit here, one of the lessons of the pandemic is the increased importance of risk management and the ability to plan for contingencies. We'll talk through how companies are using aPriori today to manage risk in both new product development and the supply chain. One of the ways we can reduce risk is by getting relevant information faster. As an example, maybe there's a small radius on the outside edge of a part that is not a requirement and is not caught in a design review. By the time it gets to manufacturing and the impact to cost and manufacturability is understood, it's too late, and a costly change order may be required. So what can we do about this? Well, aPriori is designed to cost, or DTC functionality, provides real-time feedback to design engineers on manufacturing issues and costly or slow operations on a part. Here we can see an image of a part where the highlighted section has a 0 corner radius. We can also see that this part was flagged for having features that required a tool whose L over D violated some best practices. An engineer with aPriori running gets immediate feedback and can take action back in their CAD system. Another option we have, instead of doing this on a part-by-part basis, we can identify the subset of parts with the highest DTC risk scores to understand which parts require immediate action. The way this works is you would run a large group of parts using bulk costing and analysis. You'd then run a DTC report and cost insight reports, which would identify parts with the highest DTC score to answer the question, where is all the low-hanging fruit? Another way that we can manage and reduce risk early in the design phase is by performing trade studies. These trade studies may take the form of evaluating multiple design alternatives to better understand the pros and cons of competing designs. Often these competing designs are run in both multi-physics simulation software and in aPriori for multi-domain optimization. With aPriori, you could consider design alternatives within a single commodity type, but you could also consider trade-offs that span different manufacturing processes. For example, I can use aPriori to evaluate alternative designs for a part made from sheet metal in a different but similar functioning part made as a solid laminate composite. aPriori then helps me answer questions such as, what is the piece part cost advantage or disadvantage? Are there significant manufacturability and cost discrepancies across the design alternatives? Or how does my component weight compare across competing process groups? Now, earlier this year, Fortune magazine reported that 94% of Fortune 1000 companies had experienced supply chain disruptions due to the pandemic. There's little question that there have been few times in history when supply chains were so fragile. And so it's become more critical than ever that contingencies are put in place to help manage the risk of program delays and the associated cost overruns from not being able to efficiently execute on your supply chain strategies. Companies are asking themselves, What's the relative health of my suppliers? What would be the impact of switching to a supplier in a different region or switching manufacturing processes? These questions have historically been either difficult to answer or quite time-consuming to answer. And so aPriori arms you with tools to better answer these questions yourself. For those still in an RFP phase, you can compare the supplier quoted cost in hand against the should cost estimate in aPriori to understand how competitive that supplier's quote is. This early visibility is important because once the part and supplier are certified, it can become very expensive to change suppliers. The earlier you can understand this, the better placed you are to make an informed decision. Another strategy to consider for reducing risk in the supply chain is to evaluate bringing a part in-house. aPriori can help you understand the cost to manufacture a part yourself, which can then be weighed against potentially the increased lead time of sticking with an existing supplier. And to further support different sourcing strategies, in our 20R1 release, we added support for matrix costing. Matrix costing allows a user to vary the digital factory, the batch size, and the annual volume to generate many alternative scenarios that support key sourcing strategies. So how do you go about implementing the strategies that we talk through? Well, ultimately, it comes down to creating a culture oriented toward digital manufacturing within your company. We've seen that the pandemic has accelerated many of the underlying trends from the past 5 to 10 years. So now is an opportunistic time to evaluate how you can implement these changes or these strategies to position your company well for the years ahead. Some of the earliest tools in the digital manufacturing space have become ubiquitous in the decades that they were originally released. So things like CAD modeling, CNC programming, CAM, and FEA. But there are other constituents in the digital thread, such as model-based definition and product manufacturing information, that have not quite seen the same widespread adoption. At aPriori, what we've seen is that the manufacturing companies that have been early adopters in digital manufacturing have had a competitive advantage. More recently, we've seen the importance of adopting digital manufacturing has accelerated due to the pandemic. Many employees have been forced to work remotely, which has only further increased the importance to collaborate and maintain productivity while being geographically dispersed. So what are some of the benefits of adopting a digital manufacturing culture? Well, first off, it supports future growth and innovation. Companies that embrace digital manufacturing are more agile and responsive to change, while at the same time are better positioned to execute on existing plans. It also reinforces that cost is a team sport. Cost should not be the sole ownership of finance or accounting. And the more awareness there is, and the more cross-functional groups feel a sense of ownership over cost, the more profitable a company can be. It also allows companies to extract and codify at an enterprise scale the knowledge of retiring experts. For those less experienced employees without the decades of manufacturing knowledge, they can more quickly start contributing toward program goals by interacting with the codified knowledge within aPriori. There's also more opportunities to collaborate. We talked about the rise of remote work over the past 10 months. And while it remains to be seen how enduring this trend is, what is clear is that facilitating workflows and using the collaboration tools of digital manufacturing are valuable. And finally, it increases productivity, allowing you to do more with less. So we've seen some examples of this, but think of people on the factory floor who are more empowered due to the richer data set available in the digital twin. Early on in a design, an engineer may add GD&T directly on the CAD model. Downstream, when someone runs the scenario in aPriori, those tolerances are automatically read in and update the manufacturing routing appropriately. Further downstream, when the manufacturing engineer or someone on the floor looks at the digital twin, they have the right information available to them, which only makes their job easier.
That's great stuff. Thanks, Craig. So hopefully everyone's learned a little bit about how aerospace and defense companies are responding to the challenges brought about by COVID, and how aPriori can help them to evaluate their options and reduce risk as they evolve their strategy to stay profitable through the phases we discussed here. If you'd like to talk to us about your own challenges and go forward goals, then please feel free to schedule a meeting or reach out to us at the emails on the last slide. Before we get to the Q&A, I do want to recommend yesterday's 11:20 session about how you can incorporate a focus on cost in engineering without putting a burden on your designers. It's really powerful stuff. That recording is already available on the site. So now we can open it up for questions. I do see we have a question from Teresa Lee. Does aPriori have any plans to handle the unique testing and inspection requirements demanded by the aerospace industry?
So I know that that is something that Julie spoke about a bit, about enhanced capabilities in inspection. I'll have to take an action item on that specifically and see if there's a targeted focus on the aerospace side.
And certainly, Teresa, we do have a testing and inspection module, and you may know that certainly everything can be configured, so we can build that out for you specific to your needs. Anyone else?
Looks like there was a question actually on the event website, which was that the prediction about the pandemic returning, or sorry, travel levels returning in 3 years to pre-pandemic levels. It looks like Rick Hyde had responded with some data there. What we were also looking at were some of the forecasts from Boeing in their recent quarterly reports as well.
Yeah, in their earnings call, they of course spoke quite a bit about it, and companies have been talking about 2023 earlier in the year, but we're seeing them start to push toward 2024. And as Rick pointed out in his answer here, certainly short haul is expected to recover faster, mainly because you're in country. Well, that's great. The recording will be, oh, I see another one here. What is the plan to cover aerospace raw material grades?
So that's actually something that we're currently researching. We are looking to get more specific focus on the aerospace needs in that area. I don't know offhand exactly when we're planning to provide an update for that, but it is something that we're actively researching.
That's great. And again, of course, all of this is configurable. Great. Is there anything else? Do we account for DFAR requirements? Can you expand on that? From Matthew Pizzino.
Okay, so it looks like just his follow-up was the location of the raw materials and how it's mined and made into finished goods. And I think that gets back into the aerospace specific research that we're currently doing on materials. That would be part of that effort.
That's great. And we've got to close out now. So Matthew, feel free to email me if you would like to follow up on that and get a little more detail, ptarbox@apriori.com. Actually, if you can advance the last slide.
Sure.
So those are our email addresses if you'd like to follow up for more details. So thank you all for joining us today.